All right, so the electrolytic titration demonstration requires two solutions, a 1 molar sulfuric acid solution, which is really easy to prepare, and a barium hydroxide solution. The barium hydroxide doesn't dissolve very well in water, so you have to filter it. So what I've got here is 2 grams of barium hydroxide in 200 milliliters of water. And as you can see, it didn't dissolve very well. I had it stirring for about 15 minutes. So what we're going to do is we're going to filter it with this little contraption. I'll put this rubber part in here, then I'll put this plastic cup on top, and then to seal those holes, I've got some filter paper, which I'm going to put right here. And then in order to get that filter paper to seal and stick to the plastic and not allow any of this solution, particularly any of these solid particles, to kind of get past the paper and then come down into what we want to be our pure aqueous solution, I've got the filter paper in there. I'm going to just squirt a little bit of water in, and then I'm going to attach this tubing to the flask like that. And then when I turn on the faucet, which is connected to this aspirator, I draw a vacuum, and you can see the water goes down. All right, and what we're going to do is we're going to turn on the vacuum, and I'm going to pour this solution into the cup, and I'm going to pour it right down the stir rod so that it doesn't dribble down the flask. I'll turn the water up so it filters a little faster. Okay, it's about halfway full, so I'm going to add some more. I'll just fill it up to the rim, and we'll keep it full. Okay, so now we're all done, and I've got the barium hydroxide solution down here, and ideally you want to use this right away. And the reason is because if you wait very long, CO2 will dissolve into the water, and then will form the carbonate ion, which will combine with the barium ion that's already present and form barium carbonate, which exists as a thin film on the top of the solution, which then means you have to filter it again. If you're not able to do it just before class, then what I would do is put it into a sealed jar with very little airspace so that there's hardly any CO2 in the system to cause the problem. All right, let's get on to the titration. All right, so here we go with the titration itself. So you can see I've got a burette here, and that is full of 1 molar sulfuric acid. And then what I have in this 400 milliliter beaker is the barium hydroxide. And I like to use a tall, skinny beaker, and you'll see why. It makes this light bulb apparatus sort of work a little bit better. So what we need to do is I'm going to drop this light bulb conductivity indicator down in here. And you can see like these probes only go down so far, so that's why I like to have a tall, skinny beaker so that the solution is taller than it is wide. And let's see, so I'll plug this in. And we can see that we've got ions in solution. Okay, excellent. I'm going to start stirring this, and it's not going to stir very well because the magnet that stirs it is in the center, but I can only get this light bulb over only so far. So it's not the best, but it's enough to agitate the solution. And then the other thing that I need to do is line up my sulfuric acid. But before I do that, I always like to put a little phenolphthalein in so we can get an idea of what's going on. All right, so we can see that we've got base in this solution. You can also see it doesn't mix very well, and that's all right. All right, so we can see we have ions in solution, and we can see that it's basic. Okay, and then the next thing that I'm going to do is just spin my burette over, and I think I'll drop it down a little bit. always a little tricky to get everything to be lined up. Okay, so there we go. And as you can see in my other video, I like to ask the students a whole lot of questions beforehand and as we do this. And actually what I've got over to the side are some whiteboards where we've already written out the equation, the reaction that's going to happen, and I've got the ions in solution. And along the way, as you can see in my other video, we talk about what's making the light bulb glow, why is it pink, why does the solution become cloudy, etc., etc. So I'm trying to link the symbols in that equation on the top with the pictures on the bottom with the macroscopic things that we see. All right, so here we go. You want to be patient with this, because if you add too much sulfuric acid, well, you miss the cool stuff. So you can see I added a little bit of sulfuric, and we're getting a white precipitate to form. You can see that, right? It kind of looks like cloudy milk at this point. And we can see that the light bulb is still on. Okay. So what is ideal is to just add it drip by drip. And as a teacher, you kind of have to be watching the chemistry, but then asking your students questions along the way. So I just turned the drip off. What I'm going to try to do is get the light bulb to go off, yet make the solution still pink. And the key is to do it really slowly. And we also sometimes get a delay because remember, the solution doesn't mix very well. You could stir it. Be sure that you stir it with a glass stirring rod. I wouldn't put a metal spatula in here. And it might look like the light bulb is dimming a little bit. And the key is, remember, there's going to be a delay because the solution doesn't mix well. Definitely getting more and more of that white precipitate. And certainly along the way here, I'd be asking the students, what's going on? What do we have in solution? What's the limiting reactant? What is the excess reactant? What does it mean that it's still pink? What does it mean that this light bulb is still conducting or is still lit? Will the light bulb always be lit? So you kind of need to ask questions to kind of fill the void space while it's stirring. And it seems to me like this light bulb is getting dimmer. I have a lot of windows in my classroom, so it's not completely dark in here. And if you go too fast, you'll miss the light bulb dim, and it'll just look like the light bulb's been on the whole time. But really, if we can get it so that we have the same number of hydroxide ions as hydrogen ions in the system, they will react to form water and the barium sulfate, and we should have no ions to conduct, and the light bulb should go off. Oh, hope that wasn't too much, because it kind of came out as a stream. Seems to me that it's getting dimmer. And again, this is why it's really a good idea to have the whiteboard, and you can be asking your students questions as you're killing time here. And you could maybe calculate how much sulfuric it's going to take, but because that barium hydroxide really doesn't go into solution, I assume it's a saturated solution, but I don't. Ooh, look at that. Now that light bulb is really dim. And getting, look at that. Look at that. Excellent. So now that light bulb that filament is not glowing at all. Yeah, not glowing at all, yet the solution is still pink. So there are still hydroxide ions in the solution, but there are not enough ions to conduct the electricity. So it's kind of cool how we can parse that out with these two different macroscopic indicators. And remember, phenolphthalein changes to clear around a pH of 9, I believe. So it seems like you need quite a few ions to conduct and allow that light bulb. So I think what I'm going to do now is just kind of let it drip slowly. Definitely want to get a burette that, oh, look at that. It's getting very white. Oh, look at that. Look at that. Looks to me like we've got some milk here. And now I've got ideal. This is, you know, again, it takes so much patience. As I was saying, you need to have a burette that you can control very, very well, so that you're only letting drops go. That another drop just went. And so what we've got now is it's, well, maybe a neutral solution, probably pretty close to neutral. Ooh, and I can see, I don't know if you can see, but this light bulb is starting to glow. And so we are getting excess sulfuric acid. And as more drops come into the solution, we're going to get more and more excess. We're going past that equivalence point. And we can see that because because the light bulb is glowing yet again. And you know, as I'm doing this, you know, you can still ask the students to do more on the whiteboards with the microscopic pictures, have them draw what is currently in the solution, perhaps when it was white and no light, and then when it's white and lots of light. Lots of fun stuff that you can do with this. I'm gonna let it just drip a little bit. Whoop, it's a stream there. And again, we always have a little delay because it doesn't mix well. But it's dripping a little faster now, and we should see, yep, it's glowing better and better and better. Yeah, so again, one of my favorite AP Chem demos, because it's so rich in chemistry, and you can talk about things from the symbolic level, the macroscopic, and the particle level.